Electricity 2.0. So, the first thing that I said today is the world is going solar. We have to, right? We have to, not because it's the right thing, but because there aren't enough energy sources to double or triple the consumption of energy over the next 30, 40 years. Okay? So the first thing that I believe is that in solar, I remember just 3 years ago when I published the book, I said solar is going to be 10 times bigger than wind soon. People looked at me like I had 10 heads, right? And it didn't take that long. 2011, in Europe, solar was twice as large as wind. Okay, already. And that has nothing to do with the wind industry. And it has everything to do with the qualities of solar. One is the resource, but also the industry, the technology. And I will talk about that more as we go. So, A, world going solar. B, this. And this that I'm going to talk about today is massively important. Because it's not just about the source of energy. It's about this. So, 3 decades ago, this was the world of information technology. Basements. They were bigger than people in size, right? And they were usually mainframes. They basically were out there, computers, and people were in here. We were pretty passive in consuming information that came out of the mainframes. So information moved one way. IT was centralized. It was top-down, autocratic. Only mainframe computer operators could generate, store, process, transmit, and sell data. And by extension, data was scarce and expensive. This is just 30 plus years ago. This was the world of publishing, okay? Large printers out there that filled up buildings, and readers, newspaper or magazines, that had no input into what was being published. Only a few publishers out there decided what was being published and when. Information moved one way from there to here, and money moved one way from here to there, right? And same thing, publishing was autocratic, centralized, and monolithic. And in fact, only publishers could process information, generate information, store it, transmit it, and sell it. So data was scarce and expensive. This was about 3 decades ago. And in fact, this business model worked. Look at the revenues for newspaper publishing industry. Up and to the right, don't you love that business model as long as it goes up and to the right? Yeah? Then the PC, the internet, and the cell phone transformed the architecture of energy, of data. Yeah? Totally transformed it. Now anyone can store, generate, transmit, sell, and use data. We do every day, every time we show up on Facebook, on LinkedIn, on Twitter. There are billions of publishers today, okay? Now, some produce much more data than others, But basically, everybody's a publisher now. Data/IT now is democratic, distributed. Distributed, right? Data generation is distributed, which is the key change away from the big guys to all of us, right? IT is embedded. It's embedded in everything, in our cell phone, in our video, in our camera. We can upload to Facebook from a camera. My goodness. And it's grid independent. Everyone with a cell phone is not connected to any grid. Does that make sense? And because of that, data is abundant and cheap. It's so cheap, we pay to keep it away. Right? It's called spam. Now, not just everybody here, everybody everywhere. There are 6 billion cell phones in the world for 7 billion people. 6 billion cell phones for 7 billion people. Okay? That is distributed infrastructure for data. Everybody generates data. Okay? Everywhere. So, what happened to the publishing industry? This. Okay? And that happened since about 2000. In about 12 years, they went from peak, and I don't know if this is even trough, because it's still going down. And now it's down to the levels that they were in 1950. Okay? And we may not be at the bottom yet. That's what happens when you go from top-heavy centralized architecture to a distributed architecture. Now, the same idea, the same thing that happened in data, in information technology, is starting to happen in energy. So technology advances in generation, in storage, in transmission, and use of energy is turning the architecture. So not just the sources, but the architecture of energy upside down. Okay? In my opinion, this is the future of energy. Okay? This is the future of energy. Right? And energy today is what the internet was in the early to mid-90s. Cisco has 200,000 employees. And when we said at Cisco in 1994 that this internet thing is going to be huge, of course, they looked at us like we had 10 heads. Right? And the new architecture of energy is going to be distributed, which means we're going to generate from homes, from factories, from commercial buildings, from power plants, at all levels. So just because we generate data here does not mean that Google is not generating data in billion-dollar power plants or data plants, right? So we're going to have generation and storage at all levels, right? And the electricity is going to have to go both ways. Energy is going to have to go both ways. Now it's only one way. And that fact alone means that there are going to be huge opportunities in rebuilding the transmission grid, right? And that is one of the chapters, that's one of the sessions that we're going to do. At every part, every point of the transmission and distribution and usage and whatnot, there are opportunities, okay? In the new architecture. For storage, for generation, for use, and anyone, anywhere will be able to generate, store, use, transmit, and sell energy. Just like we flipped the architecture in data, we're going to flip the architecture in energy. It will be distributed. That is the key word in the new architecture. It's going to be distributed. Just like PCs, just like the cell phone, everybody will be able to. It doesn't mean everybody will have a PV panel, but everybody can do it. And energy will be embedded. Embedded in buildings, embedded in cars, embedded in parking lots, embedded in pretty much everywhere. And grid independent. Okay? And better yet, it'll be abundant and cheap. You looked at the trends, right? The cost trends. It's going to be cheap. Okay? Now, let me give you a couple of examples. This is not just some futuristic dream. Germany already has 1 million solar installations. So they went from hundreds of power plants, big power plants, to 1 million installations. They're shutting down their nuclear infrastructure. And they're going to triple their solar over the next 7 years. Triple. Okay? California, we're going up the same curve that Germany went. So we went from about 1,000 installations to 100,000 installations, and we're going up to 1 million before the end of the decade. I'd be surprised if we don't do it by 2015 or 16.